Hey, once again, afternoon, folks. This time around, I'm taking you through one problem where we might need to apply our understanding and reasoning from the few notes that I gave you earlier. We've got two objects here. Object A is for the mass 3 kilograms, and object B, its mass is 2 kilograms. So the mass is given in variable form. Now, let's quickly go through the information and check what's required. Um, two particles A and B of mass is 3 kilograms and 2 kilograms respectively. So we can see clear that we are given the masses are attached to the ends of light inextensible string. The string passes over a fixed smooth pulley which is attached to the edge of a plane. Now the plane is inclined at an angle theta to the horizontal. So we can see the angle theta there. And the moment we see theta, we should think of the weight component and the perpendicular components, you name it. So A lies on the plane and B hangs vertical 0.8 meters above the floor, which is horizontal. Now the string between A and the pulley is parallel to the line of greatest slope of the plane, see diagram. Initially A and B are at rest. So the moment they are at rest, it means there is no motion. So in other words, from the equations of motion that we spoke about, it means our u is equal to 0. And I'm given a distance likely to be traveled, which is s. Um, Given that the plane is smooth. Now, if the plane is smooth, it means when we look at the component of forces going downwards, it means the frictional force does not apply. Find the value of theta for which A remains at rest. Now, if A remains at rest, it means the whole system is in equilibrium. In other words, if I bring down the weight of object A, but remember, weight is calculated as mg. My mass is 3m, and we know g is 10. So if I say 3m multiplied by 10, it means my weight here is 30m. But remember, we will be interested in this component should need arise. And actually, it's the weight component which is making this object perhaps rest in equilibrium. So remember, this is angle theta. So the weight component pulling the object downwards is going to be 30m sine theta. And within the string, going upwards, we have tension. And even here, opposing the weights, we have tension. But going downwards here, we have the weight of the object, 20m. Now, because we were told that the plane is smooth, then our calculations are going to be, let's see, uh, I'm going to formulate two equations. The first one is for object A and second one for object B. Because the system is experiencing equilibrium, so let's look at object B. I can say on B, what I'm seeing is there's a balance between 20m and T. That's what's happening on B. Now on A, we've got a balance between T and the weight component, which is 30m sine theta. So we are interested in the value of theta. In other words, we have to eliminate T. So in our next or subsequent step, it looks like it's clear for us that there's equality here where I'll come to say that 20m should actually be equal to 30m sine theta. You can see clear that m is existing on both sides, and I'm looking for angle theta. So I'm allowed to say sine theta is equal to 20 over 30, because I'll divide both sides by 30. Then this will cancel. So we end up having this scenario where theta will actually be inverse sine of 2 over 3. And here I'll need my calculator now to say if I'm interested in inverse sine, my calculation is going to be second function sine, then open the brackets, 2 divided by 3, close brackets, it will give me 41.8. So it looks like my angle theta is equal to 41.8 degrees. I'll be done with the first part. Now let's check the second one. It is given instead that the plane is rough and theta is equal to 30 degrees and the acceleration up the plane is 0.1. So I'll try and redraw the picture that we had. So theta, this time around, we are told is 30 degrees, and we have got object A, whose mass we were told is 3m, and there is a pulley there, and they said object B was 2m. So this time around, they are saying the plane is rough, implying now we talk of frictional force. And also remember the weight which is pulling the object down is broken into its components, perpendicular and horizontal. So from this mass, remember we got a weight of 30m. So if I want this component, it's going to be 30m cos, because the angle is known, is cos 30 degrees, which corresponds to this. And this parallel component, which will go downwards, is going to be 30m sine 30 degrees. Then here we have tension, and there we have tension. But the weight going up downwards is going to be 20m, because it's 2m times 10. So we are interested in showing that the coefficient of friction between A and the plane is actually 1 over 10 times the root 3. But remember, we are given this extra information that our A is equal to 0.1. So what's our interest here? We are going to say, because now the object is in motion and is accelerating, then Newton's law is coming in to say F net is equal to ma. So what's the net force? Is 20 minus t. So 20 m minus t is equal to ma. That's 2m multiplied by 0.1. That's our acceleration. So that was the first equation we have. Now the second one will be saying tension here, tension minus the two components we have, which is 30 m sine 30, which is this component I have over there for the parallel component of weight plus F. But we can't put a plus per se. When we put plus, in other words, we might be combining these two because they are facing the same direction. So this picture will be equal to MA, but our mass there is 3M. And 3M, it will be, when I multiply 3M by 0.1, that will be the scenario, which will give me the second equation. So we'll check if we'll end up with what's given above. Now, let me try and simplify this part. Just want to check what's happened. I'll take my calculator and say, if I say 2 times 0.1, it gives me 0.2. So as good as what I have here is 0.2m. I can rewrite this equation as 20m minus t equal to 0.2m. Then let me try and simplify the second equation, which is saying t minus 30m sine 30. Remember, sine 30 is a special angle, which is 1 over 2. So 1 over 2 multiplied by 30m. So as good as it's minus 15m plus. Friction is calculated as, or let me not confuse the calculation, properly put two subtraction signs because these two are facing the same direction. So I'll say minus mu r. But r, if we check r, it corresponds to this component, which is, when I say r here, r is equal to 30m cos 30 degrees. Remember, this 30 degrees is a special angle. It gives us root 3 over 2. So this is the same as 15m root 3. So I can multiply this by 15m root 3. We are saying this is equal to, in a similar scenario, I've got 3m times 0.1. So I'm going to say 3 times 0.1, check the result is 0.3. So I'm allowed to come and say, oh, this is equal to 0.3m. Let me proceed a bit with my calculations and check if it can help me to get mu. I could make this t subject of formula so that I eliminate t here and I deal with my mu. So if I do that, these two are going to interchange. In other words, somewhere here I can say, but t is equal to 20m minus 0.2m. So when I come and substitute it in this equation, I'll be saying 20m minus 0.2m minus 15m minus 15m root 3 mu equal to 0.3 m. So this equation that I have, I need to solve for mu. So I'm allowed to swap around these two because I want to make mu subject of formula. So it's negative here. If I swap it around, it will give me 15m root 3 mu. Equal to, because I'm just rearranging, that's 20m minus 0.2m, which is here, minus 15m, minus when I transpose 0.3m. So I'm still simplifying 15m root 3 mu is equal to, I'll need my calculator here to say 20 subtract, I have 0.2 there on the board, subtract 15 subtract 0.3. All this is giving me 4.5. So I can say all this is equal to 4.5. But I want to make new subject of formula. So I'll proceed to say, let me divide both sides by 15. M was common both sides. M was supposed to go when we simplified both sides because we put m's on both sides. So actually we end up having 15 root 3 mu equal to 4.5. We divide both sides by 15, even here by 15. Then 15 will cancel, and we end up having root 3 mu equal to 4.5 over 15. But then I'm going to be forced to also divide both sides by root 3. So root 3 and even here root 3. So it will cancel. So my final step will be, let's see, mu is going to be equal to, on the numerator I have 14.5, but on the denominator I have root 3. I'm not allowed to leave root 3 on the denominator. I'll rationalize, it goes on the numerator there, I have root 3. Then on the denominator I'll end up with 15 times 3, which will give me 45. So to simplify, 4,5 divided by 45, let's try and check. 4.5 divided by 45, it gives us 1 over 10. So I can come and say this is 1 over 10 and a root 3. So that's our coefficient of friction. We can come to check above to say what we were interested in confirming 1 over 10 and the root 3. So we've confirmed the value of 1 over 10 and the root 3. Thank you. That was the first part of applying what we learned from the few notes that I gave you guys. All right.